So our next speaker is Sergio Marchese from OneSpin Solutions, our gold sponsor. Sergio is a technical marketing manager. The title of his talk is Challenges Call for Innovation, a recipe for success and a taste of formal solutions. Sergio has 18 years experience in hardware design, constrained random simulation, formal verification, and DFT. He has built and managed state-of-the-art teams, successfully achieving formal sign-off on complex designs. Before taking the role of technical marketing manager at OneSpin, he was at Huawei, leading formal verification for ARM, CPU, and consumer SoCs.
Thank you. So this is a bit taken from my passion for cooking, but so I just wanted to stick a title there that remind me of something about cooking. And in practice, what I'm gonna do in this talk is give you a bit of insight on OneSpin, a way of work to create innovation, and touch on a couple of formal solutions as examples, so to speak. In terms of verification challenges, I think we probably agree with TVS. We see functionality still as a big challenge, of course, at the high level, but also safety and security coming out with big, thick layers of complexity. Mike, would you agree? Yeah, exactly. No, yeah. And but how do we tackle these challenges? And I think we agree that EDA needs to innovate, and we want to help you guys who develop chips and IPs, with new solutions. So I'm going to do now something a little bit unusual here, because rather than talking right away what we offer, and I'm going to talk about how we work internally a little bit in OneSpin. So if you look at the offering, you can see there are solutions on top. There are apps. So in the formal space, apps are particularly well known these days. And then there is let's say the technology. In the case of formal tools, proof engines are very important, of course. Compiler, parser, graphical user interface, command line interface. So actually, I think, the EDA company has a quite complex job to bring to you guys innovative solutions that work. So what are the challenges on our side to create innovation? And, I thought it makes sense to go into this because also it's the theme of the conference. So it's like, future organization challenge and collaborate with vendors to create solutions. So we want to collaborate with you to also create innovation. And I think the first challenge is, to understand what the right problems are. And of course, for us, it's important to work closely with users, with projects, and make sure we are tackling the right problem. It's not obvious. The second important challenge is that, as probably you guys do, in your daily work, that there are many things to handle at once. We have many customers, many different types of applications, many different challenges. And so as a company, we need to handle many things in parallel. And the third challenge, I think important challenge that we have is that when we want to create innovation, sometimes you only need to touch one layer, but sometimes you really need to go to all the layers, from the low-level technology, interface, documentation, methodology. And this in practice means that there are many different teams in the companies that are involved. So you need also to have a very flexible, agile organization to come up with good innovation. So here I just give you a quick chart of one tiny piece of our development process at OneSpin, change requests. So if we look at change requests, we have big things like new requirements. We split them down in features. And then we also have defects. So sometimes our customers find bugs in our tool. And so we also need to fix those. And so the sources are really users, our own application engineers, product managers, marketing, research and development itself. And this gives you a graphical idea of just let's say the initial step, how change requests come in. And there are, some steps here to make sure they get into our system, in the proper way. Another bit of insight I want to share is how one of the cornerstone of our software development within OneSpin is we follow an agile software development process with sprint cycles and cross-functional meetings. I don't know, now agile is obviously more popular in software development, but there is some application also in hardware. But you know, within OneSpin to develop our software, we use agile. We have roughly 1 week sprints, and very important, we have regular sprint review meeting and priority arbitration meeting to make sure we continuously deliver value to our customer and we solve the right problem at the right time. So, of course, you can say, right, why do I care how you guys do your software? Maybe some of you are thinking, I just care it works. And okay, that's probably a fair comment, but I think there is some value into understanding a little bit how your partner works internally. But there is also more than that, and let me bring you a practical example. So OneSpin is very active in the safety critical domain, in automotive, aerospace, medical application, and we were able to achieve a TÜV-SÜD certification for our tool qualification kit. So if you work into the safety critical domain, you know that safety standards force you to qualify the tool that you use in your flow, because tool could create problems, could introduce problems, fail to detect problems. So safety standards are quite strict into forcing you, user, to say, you know, I need you to prove that you have confidence that the software tool works correctly. Now, if you want to be faster be compliant with this requirement from safety standard, you can use tool qualification kits. Okay, tool qualification kits help you in this process. And the TÜV-SÜD is a German organization which is very well regarded, that provide a third-party assessment of tool qualification kit, among other things. It's a huge organization. And so if you look at the certification in our hardware development space, relevant in our hardware development space that TÜV-SÜD provides, there are two levels. One is what is called TCL1 certification, which is only applicable to the automotive standard, and the one that is applicable to many standards. It's also, it's a proper third-party tool qualification, and this is information taken from a TÜV-SÜD webinar, so finding the right software tools for functional safety projects. So you can go and look at this webinar, it's very interesting. We also have a white paper on this, onespin.com/TÜV. And at OneSpin, we were able to achieve this level of certification, this superior level of certification. And one of the things they do here, while here they basically look at documentation, in this level of certification, to grant this level of certification, they look at your development process as well. They look at project and quality management. They look at development process and testing. They actually inspected our factory. So we were able to achieve this level of certification that is also applicable not only to the automotive standard, but other standards, also thanks to our robust processes. Another thing I want to mention is formal coverage, which has been a topic today. So if you look at the traditional formal coverage, it's kind of an afterthought. It's built on top right. We have proofs. How can we try to do some quantification of what these proofs are, what parts of the design they are checking? So we have the concept of cone of inference, which is very over-optimistic, but gives some information. There is proof coverage, which is a bit more precise, but it depends on the proof engine. So you could have multiple runs that give different results. And for example, if you look at this tutorial, DVCon US from Verilab, you could see that the way this over-optimistic is mine, but the rest is taken from this tutorial. So this type of coverage is really hard to interpret, needs support from the vendor, makes review much harder. So we decided at OneSpin to take a much more, development from the ground up approach. And the goal for us was to have coverage metrics that were accurate and familiar to the user, to detect verification gaps and errors that others miss, and have an intuitive interface, be able to integrate with simulation metrics. But how do you get to this level of innovation, let's say? Well, of course, we had to do lots of new algorithms in the tool, developed from the ground up. You know, we integrated the mutation analysis into the formal model. So this is mutation analysis is integrated within our tool, and we can, of course, optimize this mutation analysis for formal, because that's our target, and we can do parallel mutation and assertion analysis in parallel. And of course, this technology is patented. And so what does it mean for the user? There is a simple example. This is one of the consequences of this. This is a small toy example. It's just one module. You can actually copy it from the slide and run it if you have any formal tool. And for example, here there is just a small counter that counts up and down. And on push, it counts up. On pop, it counts down. And if you have a couple of assertions here that are checking something, but they are checking something about the counter register, but they are not really checking the push and pop operations, okay? So if you run the traditional proof coverage analysis, what you're likely to get is that you get all greens. Everything is covered. Well done, job done. If you actually run our tool, Quantify, it will spot you the gaps. So this is a very practical application, of what it means developing a solution for the ground up, and what are the consequences also for the users. So if you want to know more about our coverage tool, Quantify, you can go to onespin.com/quantify. The important thing here is that, the difference with a solution that is over-optimistic compared with a solution that actually finds the portion of code that are not being verified. Another application, which I will quickly go through, I don't have enough time, but it's a proof of complex arithmetic, which is something that is known to be hard for formal tool. We work with Xilinx to verify the floating point unit. And again, the point here is that you can have a nice, we have a nice assertion-based verification IP for the FPU verification that makes the use very easy. But then if you don't go to the proof engine level, to the technology level, to make sure this proof can actually run, and the tool is able to tackle the complexity of floating point multiplication, for example, then there is not much use in the overall solution. If you want to know more, and if you are particularly interested in a floating point verification, go to onespin.com/FPU. So to conclude, we are also engineers, and I think for us the challenges are make sure we identify the right problems, make sure we cooperate closely with you guys, developing chips and IPs. And when we develop innovative solutions, sometimes we have really to bring together all parts of our company and the customer, of course, to make sure, we tackle all layers of our tool, from low-level proof engine, possibly compilers, interface, methodology, documentation. And for doing that effectively, we believe we need very agile but also robust organization to make sure we deliver, good solution, but that also high quality software. Thank you.
Yeah, thank you, Sergio. Any questions, Sergio? There's 2 questions.
Hi, it's Karthik from ARM. I've got a couple of questions. So first one is, what's the overhead of using Quantify?
What's your?
Overhead in terms of, engine time.
Sure.
And the second question is, would Quantify work on conclusively proven properties only, or could you also extract useful numbers out of bounded proof?
Sure. So let's go from the second, which is easy. Yes, Quantify supports bounded proof, so it will accurately quantify bounded proof. That's important because you often have bounded proof and you want to make sure you correctly account for them. So yes, Quantify supports bounded proof. The other question is basically runtime. That's of course depends. You can also run, on different levels. So if you want some quick and rough results, you can get them. Otherwise, the runtime depends, on the complexity of the design. But typically we aim for a use mode where people can run at least good accurate coverage overnight, and perhaps on a weekend regression can be, the precise, the you know, the longest run. But yeah.
Thanks. One more question, Sergio, and then we'll go to the next speaker.
Hi, this is Bala. I have two questions. The first question is, OneSpin supports VHI and VLI formats of assertions. So is there any plans to include this VHI or VLI formats of constraint writing into some standard thing like Accelera?
So VHI and VLI, you mean the OneSpin proprietary language?
Yeah.
So is there any plan to?
Put it into Excel.
Put it into some common place where LRM or...
No, I don't think so. No, we don't
Okay.
plan to make
Okay.
you know, a standard from our proprietary language. No.
Okay. Does Quantify produce coverage database which can be merged with some other vendor tool produced coverage data?
Yes. So Quantify produces coverage data that can be exported in any format. We have built some XML format that you can merge, for example, with through UCIS. And yes, so basically you can merge Quantify results to other coverage databases. It's possible. Yeah.
I think we've actually done it in TVS. Actually, we've merged OneSpin with through UCIS. So there's an Excel standard for unified coverage called UCIS, and you can merge OneSpin with, for example, cadence results and functional coverage as well, as an example.
Thank you.
Thank you. Thanks, Sergio.